All right, so hi everybody, my name's Mark Daley. I'm the Director of Digital Strategy and Biz Dev for a company called Epsilon. We provide connectivity solutions to the world's communication and cloud ecosystems. And personally, I focus on looking at new trends and technologies, anything that's sort of impacting the world of communications. And today I'm going to talk really about future trending in terms of programmable telecoms. So hopefully I'm presenting a fairly interesting and new topic. Really what I'm going to talk about is the evolution of telecoms as a resource and how exposing telecoms functions in a programmable manner is changing many aspects of our business and industry, and it's even now starting to impact the internet exchange world. So today I'll talk about how we present these telecoms functions as kind of like a tool set, and not just for telecoms folks, but other people and industries via tools like portals for use by our end customers and others, APIs to other telcos using capabilities like SDN and SDN interfaces, APIs.
Sorry to interrupt, we can't see your slides.
Oh, really?
And then they vanished. If you could start them again, that would be great.
Okay, that's kind of weird. Let's try it again. So let me know. You can see them again?
Now we can see them.
I can see. Yep, that's it.
Yep.
Now we can see them. Perfect. Yep,
okay.
All good.
Apologies. I'll just stay on this slide. So what I'm really talking about on this slide is around the trend for programmable telecoms to feed into functions like internet exchanges, telecoms functions that are presented via portals, APIs, etc. And then what I'm going to do as well is focus on the impact to the business world about what we're doing within this programmable telecoms world. So hopefully all are interesting and kind of very new topic for most of us. So programmable telecoms isn't a new concept. Actually, it really started with voice services and something called IN products or intelligent networks back in the 90s. And telcos started discussing the concept of presenting voice functions in particular as a programmable element in other applications. And sorry, this is kind of, here we go. I'm on the wrong slide here. So really what happened was that we had a technology, I'm just trying to get to the right slide. I do apologize for the hiccups. So we had a technology that was first created called Parlay, and this was the first kind of major step in how we presented functions as programmable elements to telecoms developers. So the focus was telecoms developers. This Parlay thing now is actually called One API. It's the current GSMA standard for telecom third-party APIs, actually, so it still exists. We then evolved to full architectures such as Jane, if anybody's heard of that, and that means Java APIs for integrated networks. So these are all in the sort of the 90s and the year 2000s. And then to provide additional programmable functions such as messaging, companies started being formed. There was a company on the west coast of the USA called IntelliPeer. And IntelliPeer actually still exists, by the way. They started developing kind of programmable single elements like messaging. And these type of programmable single elements started getting more and more of them. And eventually, this kind of capability and this set of capabilities led to the success of companies like Twilio, and I'll talk about Twilio in a minute. Data networking sort of began evolving its programmability over this period as well, mostly focused on sort of open standards, a lot of manufacturer involvement as well. But the manufacturers started sort of catching up and started leading the way as well, and this drove some particular issues in terms of programmable telecoms. I'll talk about a bit later too. So what we are now, we're at a point where we've really have an evolved set of APIs for many different functions. And on the next slide, what you'll see is that basically there's kind of 7 sets of APIs that telecoms people should recognize, or recognize at least some of those APIs. So these have become or emerged in our telco space as really kind of, I guess you could loosely call them telco standards. So these are industry standards being developed by industry bodies like the Metro Ethernet Forum and TM Forum, and they have packaged sets of APIs. Independent telcos, Epsilon, for instance, we developed our own APIs. A number of other telcos have as well. Vendors, they've developed their own APIs for their own software stacks. IaaS or EaaS, the cloud guys for layer 2, layer 3 interfaces into their cloud stacks. And, you know, they have literally thousands of functions now. AWS, if you go to their events and that, it's mind-blowing. PaaS and SaaS companies too. So they've developed their own application stack, programmable interfaces. And then finally, and maybe even more interesting for this community, is that community APIs where developers and engineers specifically from telecoms have created really interesting tool sets. Say, there's a really interesting one to Google called Napalm, which is about network connectivity over lots of different network elements. Really interesting topics. And I'm sure there's many others that the audience is familiar with as well. So we now have these kind of sets and standards of APIs that are very, very applicable for us, at least in the telco space. So then the type and complexity of service functions being presented through programmable telecoms is continuing to evolve as well. And this is also driving change in what we've come to know as SDN, or software-defined networking. So as SDN is maturing, the functions presented as controllable and programmable capabilities, they're increasing as well. And you can see on this graph on the right-hand side, the stack that you get within the SDN environment is just keeps growing and growing. Micro functions such as policy control, identity management, security elements, they're all now being presented as mini resources even within the SDN environment. And so even the SDN stack is continuing to evolve. So then if we look at, okay, I'm talking about programmable stuff all the time. So if you think about this, programmable telecoms functions are enabling the monetization of telecom services in kind of different ways. And we're not always taking advantage of that as telecom service providers. Communications platform providers, or CPaaS, as a sort of communications platform as a service companies, they present telecoms as a resource to developers, as tool sets for new and innovative ways to enhance others' applications, like their customers' applications. A good example would be a calling function within a taxi app, so the taxi driver can find where you are. So it's the CPaaS guys who have created and monetized these new types of approach to enabling business applications. And they've been really successful in this monetizing capability. And they're usually doing it with services that we provide, and they're monetizing functions that we never were able to in the past. You can see on the slide here, there's like a couple of revenue estimates. They're kind of wildly different, but they're both really massive. But here's a really interesting example. So this company, Twilio, if you've never heard of them, give them a Google search later. But their revenues are now at about $1.134 billion US dollars. That's billion US dollars. And what they do is they sell our services. They are not a telecoms company as such. They present telecoms functions as a resource to the developer community to then utilize them in other functions. So these companies have done very well through programmable telecoms to monetize new services, probably far better than we have, unfortunately. So interestingly enough, I'm very old. And as telcos, we kind of had our chance at a lot of this and we missed it. Graphical and even programmable service functions have been available to us for a long time. But we've tended to keep it a secret, and we just use it, or used to use it, for ourselves. So for our own engineers, our own kind of service creation. The example in this slide is a graphical call flow engine from an IN platform just after the year 2000. So on the left-hand side, this is kind of what some of us telcos could use, but we always used it internally, and it's for a voice service in this example. On the right-hand side, this is from Twilio's Flex offering that they launched in 2018. So about 17, 18 years after we already had this. And they allow others to create their own call flows, basically just present it out as a graphical interface. And you can go and create your own call flow as a developer or even as an admin person. So the genius of companies like Twilio has been to expose these functions to the development community, who have then sort of created interesting and innovative uses for their own companies and customers. And this is the continuing trend which continues to impact and drive us today. So telecoms as a resource and its solution components have really already become tool sets for others. And where I'm leading now is, if we start to talk about sort of as an industry, we are working on how to take the next step to support functions such as digital product threading. That's a big one for us as an industry now, is threading products together in a programmable way to deliver solutions, creating those service tools to enable that, and building ever more sort of interworking and interconnected business orientated ecosystems. So as an example, systems integrators are out there now looking for tool sets that enable them to build sort of bigger and better and easier to deploy end-to-end integrated service solutions for their enterprise customers. And using these tool sets to interwork not just functions and services, but also the business ecosystems themselves becomes very interesting for both the SI and ultimately for their customers, the systems integrators. So I've got an interesting example here. So many industries are seeing digital and online capabilities changing, if not disrupting, their own traditional segments. Banking's a great example where certain sub-segments, such as the younger consumer demographic or millennials, are being targeted with agile, on-the-move solutions with more visibility and usability than traditional banks. This company here, Monzo, they're a UK company. They don't have any high street branches. They're fully online and app enabled. They're wildly successful. In the UK now, they're the most recommended bank. And as we know, banking in Africa has had a digital lead for many years. So we see a lot of digital change in this particular segment as an example. And that's being led by the ability for people like telecoms companies and other functions through programmable networking and programmable functions. All this change has already impacted us in the telco world. We've already, for incumbent telcos, had a lot of non-traditional challenges, particularly to market segments like the SME for services like voice and contact solutions, and it's now moving into the data world, and we see non-traditional challenges even in global telecoms. So programmability in telecoms is good, but it's also a challenge for some of us telcos that have been around a little longer than a couple of years. So if you were thinking about, okay, what does all this digitization kind of mean to my company? And if I wanted to present my services in a more kind of e-commerce or digital model, what I've done is created kind of a list of the 6 key functions that if you were going to present, say, a portal, this is where you would start, or I think from my perspective, I would recommend where you start. So the first step is thinking about visibility. How do you make your products visible? And it's like me wanting to buy a new shirt. So I go online to like Amazon and I'm looking for shirts. So presenting that category, and then Once I've found it, I need to configure the shirt. So I want a white shirt, I want size large. For us in terms of services, that's like I want a 1 gig service and I want it for 12 months from here to here. So once we configure that service, we get a price. So being able to present that price, I like the price, I can order it. So online ordering has become really, really big, certainly in some sectors of the marketplace right now. So I'm placing the order. And this is where we kind of transition into something called orchestration, or part of the SDN function is I now have the spec through the configuration. I can push that down into the network layer and spin that network up through SDN or orchestration. We call it deployability. And then the final one is, okay, now I have a service running. I can see that the value of the service, I can see it's green, everything's great or not. And I can manage it. If I can see, like visibility is control. If I can see that service and how it's behaving, I can do something about it if it's not behaving in the manner that I want it to behave. So where's all this kind of leading to, and particularly relating to the IX? So first off, sort of in analyzing where this next generation of network is heading with all this stuff going on, I just want you to think about this. It's all about the app. It's all about the business application or the consumer application now. That's exactly the thing that ICT people focus on. So the massive rise in this hybrid cloud-enabled applications and the creation of remote data and apps that are all over the place means there's more and more need to provide good mission critical connectivity and address that interworking element. So this is very, very good for telecoms companies. ICT people face more and more challenges to improve the application accessibility, the perceived performance of the application through networking. And they have a real challenge in integrating not just the applications, but also the networks that enable the applications and present a user experience and a computer to or system to system experience as well. So as applications start to be classified as, say, mission critical, so too is the connectivity they depend on. So think of connectivity as mission and non-mission critical connectivity. And that makes it a lot easier to start to talk to ICT people about what it is, the problems they're trying to solve. So the next step is presenting different internet and connectivity options, I think, as part of a manageable enterprise network, focusing or enabling access to and from different business applications using the network tools that are available. And of course, the internet is a really big part of that. So the coming together of the need to access more and more varied applications, more efficiencies and better performance means that the internet exchange is going to directly become part of the enterprise networking. And we're seeing trends for that to happen right now in Western Europe. So it's already happened in a couple of the exchanges, and you can see some of the logos sitting behind me where they're experiencing this right now. So we all know that what enterprise needs are from a comms perspective. You probably hear about it all the time. I need this, I need this. But interestingly, it's my belief that the ability for internet exchanges to help with these drivers is definitely there. From an IX perspective, there are probably 3 elements that will become a focus for the future in order to support enterprises. And that is to support the continued verticalization of the IX community. So more and more layers of types of companies, to enable IX functions to be programmable and to enable the ability of cause and effect and other sort of business rule functions to be built and deployed for automation. So it's a real kind of challenge to the IXs, but I think they can deliver it. And then in the future, it's my belief that through programmability and AI, applications will start to be able to drive the network as well. We already have the pieces in place. They're only now starting to be presented as interworking functions at the different network levels, but SD-WAN is a very good example. So it's a good example of how our application is becoming visible, or applications, and they can have their own policies and end-to-end views with just a few keystrokes. And then if that data is delivered and presented down and pushed down into the physical network, then it could be that the application says, hey, you know, I'm the CRM system, I'm mission critical, I'm going to take preference over Netflix, as an example. I don't want to pick on Netflix, but and so the application is telling the network that it needs more bandwidth, the network needs to expand, etc. And the pieces are just about there for all this to happen all the way through the layers. Now, of course, we've kind of had a lot of these functions available before, but remember, the magic is exposing it to others, whether it's other network layers or other technologies or other companies. So finally, I think the summary needs and drivers for the evolution within the IX and its community include improving the ecosystem integration, developing multifunction and multi-purpose APIs, probably enabling more visual control of and federation of services, driving automation of the peering function itself, definitely, giving external access to companies like Epsilon, perhaps, so that we can control and enable things like remote peering and use and integrate our SDN, present more and more statistical and decision-making data. Link can sort of give more access to defined sets of network fabrics, communities, so presenting communities, perhaps creating sort of different commercial models, or maybe not, and thinking up interesting functions as a service. So wrapping up, I see the internet exchange is becoming more than a community exchange point, but also a resource for managing how sort of all companies can be efficiently configured and enabled to function better. So that's it. So I hope you've enjoyed the presentation, and I thank you for your attention. And I'm not too sure if there's any time left for questions, but there you go.
Thank you very much, Mark. We've got one question for you. And that question is, what would the perfect IXP legal status in line with service evolution can we deploy at an IXP, association or commercial?
I think it's a combination of both, actually. So from my perspective, there is an ability in the future to monetize enterprise type enablement within the environment, but I think both. I think as an association, we already see right now that banks are keen to join up with what you might call commercial IXs. And so that seems very acceptable to the banks. The only question that sort of large enterprises might have is the package of an SLA. I think the type of entity that's managing the IXP as a business isn't as big a consideration as the end-to-end sort of SLA, and those big guys are very traditionally minded when it comes to service levels and guarantees in particular. From a commercial perspective, managing IXPs, I'm seeing right now that, in my opinion at least, there's very little difference in terms of success in addressing these newer segments between what I would call sort of more membership-orientated IXs like Links and more commercial orientated IXs or for-profit type IXs that are out there as well. I think they both have equal success. I think it's going to be more about the service bundle and the guarantees. I hope that answers your question.